Tonight we're working with a system of equations that involves floor functions. So let's just briefly review with a numerical example what the floor function does. Let's take the floor of, let's say, 16 over 5. You could write 16 over 5 as 3 1/5. And so the floor of 16 over 5 is actually equal to 3. Now this is sometimes called the greatest integer function because it returns the greatest integer that's less than the input. Now notice 16 over 5 is 3 1/5. So 3 is the greatest integer that is less than 16 over 5. Now let's go ahead and do the reciprocal of this to do a contrast. I guess it's just, I could pick any fraction or any proper fraction, but notice that if we do the floor of the reciprocal here, this has to be equal to 0 because 0 is an integer and it's the greatest integer that is less than 5 over 16. Okay, so again, this floor function that's modern terminology, but this used to be called, the square bracket symbol used to be called the greatest integer function. Okay, now tonight we're looking for a pair of rational numbers. That's what Q stands for. Positive rational numbers is what the plus stands for, that have a product of this strange looking fraction 176 over 105, and the sum of their floors is equal to 6. Now remember, the floor function always returns, I'll just put question mark here, for any real input, the floor function is always going to return an integer. Okay, always will return a member of the set Z, the set of integers, okay? So we're looking for, again, a pair of rational numbers, positive rational numbers, whose product is 176 over 105, and whose the sum of the floors of these rational numbers is equal to 6. Now, it turns out, not surprisingly, it's quite useful to look at the prime factorizations. This is easily obtained. It's something you could do. It takes maybe 30 seconds to do this. But 2 and 11 are the only prime factors of 176. That can be seen by successively dividing by 2. And then 105 just has 3 distinct prime factors, namely 3, 5, and 7. Now, one thing that's kind of useful here, although you don't necessarily have to know it really, is that if you increment these divisors, or excuse me, these exponents, that gives you the number of divisors when you form the product. So in other words, 5 times 2, which is 4 plus 1. 4 plus 1 is 5. 1 plus 1 is 2. That means that 176 has 10 divisors, or that would be 5 divisor pairs. Okay, so that's kind of useful because it kind of gives you a terminate condition. You know, if you're trying to eliminate possibilities or you want to know when to stop, even though I didn't quite use that to its fullest extent. Now right here, again, you ink each one of these exponents, so you would get 2 times 2 times 2 equals 8 divisors. And let me be the lazy man and put a quote there. Okay, so that says that 105 has 8 divisors, and you can write them down if you want to, but it's a nice way that depends on the prime representation to determine the number of divisors. Okay, so we're going to go through now and do a little bit of brute force here. And I didn't go through each of these possibilities because you can kind of eliminate a lot of them in your head. Now, the very first thing I did is I just took a 2 away from the 2 to the 4th, and this became 2 times 88 over 15 times 7. Again, I'm just trying to mix and match here to see if we can get a situation where the floors add up to 6. Okay, so 2 times 88 is the 176, and 15 times 7. And again, I'm just rearranging these prime factors to get these divisors. That's the benefit of writing the prime factorization of the numerator and denominator. Now notice though that 88 over here, 88 over 7, 88 itself, or 88 over 7, excuse me, is equal to, what is it going there, 12 times? So it would be 12 and 4/7, right? So it's bigger than 12, but it's less than 13. So its floor is 12. And of course, the floor of a proper fraction, as we've seen, is just equal to 0. So you see, this is not a solution. We wanted it to add up to 6, right? So this isn't a solution. So we go back to the drawing board, and all I did was just swap these around, right? I left the denominator. You see, there's no magic to this, and I didn't want to go through every single possibility because you can kind of eliminate some as you go along. But in a similar fashion, you're going to get 88 over 15 has a floor of 5. 5 times 15 is 75. Okay, I won't write out all the arithmetic there. But again, this is not a solution because we are looking for 6, right? All right. Let's keep going. And again, folks, I didn't try any more of the 88s because you could tell it would be too small. I could have tried 88 over 35, for example. All right, but you're not going to get anything close to 6 if you go with bigger divisors, namely 35 and 3. 35 here, 3 here, or switch it around. So I'm not writing a lot of it down, but you can kind of tell you can save yourself some work just by noting how far away the floors would be from 6. Okay? So now right here, what did I do? I just turned it around. And again, we got 3 when we did it this way. Okay? So again, just hopping along, kind of brute force checking possibilities. All right? All right, so let's keep going. Now 176, here we struck gold. 4 times 44 is 176, and you can tell that just by looking at the prime divisors again, or the prime factorizations. But anyway, 4 over 15 has a floor of 0, and 44 over 7 is the same thing as 6 and 2/7, right? 44 over 7 is equal to 6 and 2/7 as a mixed fraction. So 44 over 7 is a number between 6 and 7, and by definition, that means it has a floor of 6. So this is the solution. And it turned out to be the only one I found. And don't forget, we were looking at an equation where we needed the product to be 176 over 105, which we're forcing because of the prime factorization. And we wanted the sum of the floors to be 6. And so we do have a solution. Now, I'm not claiming that's the only solution. I think it probably is, but I didn't go through every single possibility. I went through a few more here where we dealt with the case 21 and 5. 21 and 5 have a product of 105, right? But again, we fell a little short here. 44 over 5 is a floor of 8. Again, 4 over 21 is a floor of 0. So that doesn't get it done. We need a 6. And then all I did was try with 3 and 35. That's another possibility. If you looked at the prime factorizations, 4 times 44, 176, 3 times 35, 105. And notice, again, we didn't even come close. 1 plus 1 is equal to 2. Now, I didn't check everything, but you can envision making these numbers. If you start, you can try the other possibilities if you want to, if you think there's another solution. But I tried the ones that I thought would be the closest. And we did get pretty close with 5 right here. All right, but didn't quite get it. And I had to double check this 88 over 15. 88 over 15 is equal to 5 because 5 times 15 is 75. So that's equal to 5 plus, or 5, we can say plus, we'll just write it in the mixed form. 5 and 13/15. 5 times 15 is 75. 75 and 13 is 88. All right. So again, we were sort of close here, but we needed 6, right? We needed 6. Again, that's off the screen, but we needed the sum of the floors to be 6, okay? And so anyway, this is the only solution, and I would bet hard-earned money that this is the only solution, but I didn't check every one of them. And these things can elude you sometimes. There's quite a few possibilities if you consider the fact that you have, up here you have 10 divisors means 5 pairs of divisors, right? And one in the number is never going to work out right because the floor of 1 is just 1, so you're never going to get there with that. And then you would have 4 divisor pairs here. So I haven't gone through all of the possibilities, but I was thinking about them as I was doing it, and these are the only ones that came relatively close. And this first one's not even close. I just did it to get started, right? 5, 3, kind of in the neighborhood of 6. We got 6, one solution right here, and then 8, and so on and so forth. But that's it. This is, as far as I know, this is the only solution. So the answer to the question would be 4/15 and 40. Whoops, excuse me. 4/15 and 44/7. Let me write that down. So x would be 4/15, y would be 44/7, and you could write it either way. 4/15 and 44/7. Come up here. And y is 44/7. And you can double check, you know, in case I made a mistake here, but it's clear that the product of these twos, you know, it's clear that x times y is 176 over 105 because of the prime factorizations. You can just tell 4 times 44 is 176, 15 times 7 is 105, so that's satisfied. This has a floor of 0. Floor of x is equal to 0. Okay, and then the floor of this guy here, the floor of 44/7. And I showed y'all downstairs, but just in case we want to keep this all in one spot here. The floor of 44/7 is 6. Okay, so let me get this circled in kind of a vertical sort of way here. Whoops. Okay, so there's our solution, folks. X equals 4/15. Y is equal to 44/7. Good night.